This chapter, chapter 7, is about sampling distribution, taking samples. Okay, so that leads us to the last two parts of chapter 7, 7.2 and 7.3. Okay, we're going to do those together. 7.2 talks about proportions. 7.3 in your book talks about means. Okay, it's very similar. They're both very similar, so that's why we do them together instead of separate. Okay, so first thing we got to do is when we're working with a sample. So in the question, they tell us, hey, we took a sample of 30 students. We took a sample of 100 adults. We took a sample of 50 bottles of soda. Anytime they tell us there's a sample, this data comes from a sample, we're going to have to use, there's some assumptions we have to make about the population, right? Because if I took a sample of 50 students, a random sample of 50 students from Central High School, that's a lot less than students that there are. There's a close to 1,000 students on our campus right now, okay? If I took a random sample, even if I took a good random sample of 50, right? That's not all 1,000, right? So in order for me to use my sample, I have to make some assumptions, okay, about the population because I don't have everybody. I don't have everything, okay? So these are the first things, okay? Sometimes they're called assumptions, sometimes they're called conditions. It's the same thing, okay? The first one is the sample that you have or the sample that they're talking about. Is it a random sample? Did they do it correctly? Okay. Most of the time they'll say they took a random sample. Okay. So that's the first one. So we're going to we would set up a table that kind of looks like this. Okay. So the first assumption is the sample we're dealing with. Is it a random sample? Did they take it correctly? Did they use the correct procedures for a random sample? Yep. So we just say stated. Okay. Or if there is a problem with it, they didn't do it correctly, we would explain no, because this is wrong, and we would explain. But rarely is that the case. Okay, I don't think I've ever seen a question where, on a test or a quiz anyway, where they did it wrong. They always do it right. Okay. The second one in red is sample size. It's called the 10% condition. The sample size cannot exceed 10% of the population. Okay. Because this is so that sampling without replacement is similar enough to sampling with replacement, right? With replacement means I put the cards back in the deck, right? So if without replacement means I don't put the cards back in the deck. Well, we don't know which one they did, so the sample has to be smaller than 10% of the population size, okay? So we say 10% condition, and then we check. What's the sample size? Is that less than or equal to 10% of the population? Okay, and then it's either yes or no, and we move on. Okay, the last one, the third one. The third one breaks off into two. It depends if it's proportions or if it's a means question, averages. Okay, we're going to start with proportions. So proportions, this has to be true. The third one is, can we assume normality? Okay, so if you remember the last part of the notes, the last slide of the last notes, right? What happened to each of the top ones as we took more and more sample size, bigger sample sizes? As we raised the sample size, what happened to the shape? Exactly, right? Started to look like more normal, less, start to the V, variability, right? That's what we're checking for. Okay, we're checking to see if, hey, if it started like this, if I take a big enough sample size, it'll look like this, or like this, or like this, right? Doesn't matter what it started as, okay? All that matters is what the sample size is, okay? So for proportions, we use this little formula here. They use Q, but Q is 1 minus P, okay? So we've kind of seen this before, N times P, the number in your sample times the proportion they gave us. If I multiply those together and that's bigger than 10 whole, we're good. N times 1 minus p. So whatever number you got here, subtract it from 1 whole. If I multiply those two numbers, is that also bigger than 10? If that's true, then our sample size is big enough. Okay, because it's kind of funny, because 2 says the sample size has to be small, right? Less than 10%. Number 3 says it has to be big enough. So it has to kind of be in that sweet spot. Okay, big enough that we can assume normality, small enough that it passes the 10% condition. Okay, that's for, so the blue ones, blue, 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 that's for proportions. The only other one is, see, there's 2 normalities. One's for proportions, one's for means. This one's a little easier. They'll tell you in the question, hey, the population is normal. They'll say this is based off of normal distribution. Perfect. Stated. If they don't tell us that, then hopefully our sample size that they took is big enough to satisfy what's called the central limit theorem. Okay, central limit theorem says this. When do we get to this? When did we say we got to this? When what happened? About 30ish, right? That's the central limit theorem. Okay, central limit theorem says if you get big enough, if a sample size is large enough, you can assume normality. How big is large enough? About 30. I've heard 25, I've heard 30, I've heard 35, you're safe with 30. Okay, if your sample size is greater than or equal to 30, it's big enough to assume normality. Okay, that's with means. The hardest part about this is students get messed up because they think they're doing a means question when they're really doing a proportions question. All students every year I've taught this can do great with these. This is not a problem, right? The problem is when they look at a question, they're like, is this a means question or is this a proportions question? Do I need to do the blue guys or do I need to do the green guys? So that's what we're going to focus on the most, okay? We're going to do a lot of practice here, but that's anytime we need to do questions that are questions that are based off a sample. We do these. If it's not from a sample, we don't have to do these. Okay? Okay. All right. They're going to ask us about center and spread. We kind of talked about this before, but this is how you answer. Center and spread. So center is the mean. All right? Means talk about center. So center. Center. And then the bottom are spread. Okay. These 4 formulas you do not have to memorize because they're on your sheet. They will be given to you on testing. Okay. But you just have to know that one's for center, one's for spread, two of them for means, 2 of them are for proportions. So if they ask you, what is the center of the sampling distribution, and it's a proportions question, you're going to use this guy right here. Okay. What is the spread, or what is the variability for a sample distribution for a proportions question? We're going to use those. Same thing for means. We'll use those and that for center and spread. Okay. We're going to go over, you can see this section 2 and section 3 are very heavy in calculations. Practice. So that's what we're going to do, but I'm just going over the background of these. Okay. Because that's what they're going to ask you. So the first question we should always ask is, Is this a means or is this a proportions question? It's not hard to tell, but it's not hard to tell, but sometimes you forget to think about that. Okay. All right. Okay, so let's look at the first question. Okay. All right, first example. According to the National Center for Education Statistics, 20% of students who recently earned bachelor's degrees, were business majors. Okay. Imagine taking an SRS of 300 students who recently earned bachelor's degrees and calculating p hat. Okay. P hat is the proportion of students from the sample, right? P hat comes from the sample. Who majored? Should be a W there. Yeah. Who majored in business? Don't worry about the questions. We're not worried about the questions right now. Amy, we'll do those later. We'll do those in a few minutes. The hardest part about this, when you start doing these, is which steps do I follow? Do I follow my proportions or do I follow my means? So what type of question is this? Is it a proportions or is it a means question? And how do we know? Take a wild guess. I'm pretty sure it'll be correct. It's a proportions question. Why is it not a means question? P hat is a proportion. That's one dead giveaway, right? P hat is a proportion. Yeah, absolutely. It's proportions. What's another dead giveaway for not being a means question? It's talking about a proportion. Anywhere in there, is there anything about means? A mean of this, an average of this. Is there anything in there with means? Not a thing, right? But there's a bunch of giveaways for proportions. P hat. It actually uses the word. Does it use the word proportion? No. Does it? Proportion, yeah. And what do you see? I see percentages. Those are proportions, okay? So this is a proportions question. So we're only going to use things under proportions, not means. So on the board here, I'm only going to use the blue ones if I need to. Over here, your equations here, I'm only going to use these guys here if I need to. I'm not going to worry about anything means related because it's not a means question. Okay. Okay, so now let's look at the actual question. Identify the mean of the sampling distribution. So identify the mean is another way of saying find the center. Okay. And there's also a p hat right here too, right? Okay, so let's go up. So this is the one we're going to use. Okay, so let's write it down. Okay. So what does this mean? What this means is, so you remember, let's go back to, what was it, Monday, was it Tuesday? When we did the cards, right? When we did the cards. All of those X's are p hats. I should have used p hats instead of X's. But all of those X's there are p hats. They're samples that you took and I took too, right? If I was to find the average, if I was to keep doing that forever and ever and ever, the same thing we did back whenever we did this. If you weren't here, you can watch the video to what we did. What would the average be? So if I kept doing this, I stopped at 36, right? Each of you guys, actually, we did it 6 times each, right? So we did it about around 60 or 70 times. There should be about 60 or 70 x's here, right? Yes. If we did it 60, 70 times, if you kept doing it a million times, a billion times, an infinite number of times, and then I stopped, added up all of these decimals, 0.2, 0.3 plus 0.3 plus 0.3 plus 0.3, and added them all up and divided by however many there were, what would the average be? It would be exactly 0.5, right on the dot, right? It would be exactly 0.5. That's the true proportion, right? So that's what this question is asking here. That's what this question is asking. If I were to take samples of 300, 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 and for each of those 300, I had a p hat. And I added all of those p hats up and divided by however many samples I took. What would the average be? 20, it would be exactly what the population is, right? This says that this talks about the population. It says according to 20% who recently earned were business majors. That's the population. That's a parameter right there. So if I were to do all of that, take samples of 300, take samples of 300, right? Graph them like I did here. They would equal what the parameter is. In this case, the parameter is 20%. No calculations to be done, but unless you understand, you're not going to be able to do it. Okay. All right. Letter B, calculate and interpret the standard deviation of the sampling distribution of p hat. Okay. So standard deviation refers to spread or variability. Okay. So we're going to go back up here. Now we're going to use the second one. The standard deviations of all those p hats. How much variability is there? That's what we're calculating. That's what we're going to calculate right now. Okay. So first thing we got to do is calculate it. So the equation that's written on the front or written on the board for proportions is P times 1 minus P divided by N square root. Okay. So let's start filling in numbers here. What's P in this case, what is P? What's the true parameter, true proportion of students who are 0.2? Okay. 1 minus P over N. What's N? 300. They took a sample of 300, it says, right there. Okay. Let's calculate it. Okay, so 0.2 times 0.8 divided by 300 square root. So I go 3 spaces and I get 0.023. Okay. So that's the standard deviation, that's the spread. Okay. Couple other things they've asked for. A couple other things we're going to go over. First thing they did is to interpret that. Okay. So we got to interpret what that is. Well, if we're interpreting standard deviation, it's the average distance of all of the data points from the mean, right? So instead of we got to enter some of those things, we got to like talk about p hats. So we would say the mean, since the average of all the p hats is 0.2, each p hat will vary by 0.023. What is 0.023 in this case? In context, what is 0.023? No. It's a percentage, right? Yeah, exactly. It's a percentage. So what you're saying is my sample should center around 0.2, give or take about 2%. Give or take about 2%. That's the variability, right? I should, if I do a sample, if I do a good sample of here, it should be centered at 0.2, right? But there will be some variability. There'll be some variability by about 2% either way. Okay. What if I wanted that to go lower? What if I wanted 2%? 2% is too big. That's too much variability. How would I lower that variability? Bigger sample size, yeah. Because that's the number that's getting divided, right? So you guys know that if the bottom number of a fraction gets bigger, what happens to the overall fraction? It gets smaller, yeah. Makes sense, right? Okay. So we did one, we've calculated, we've interpreted. The last thing we got to do is verify condition number 2, the 10% condition. We don't got to do the rest. We just got to do number 2. Okay. So 10% condition. Okay. N is less than or equal to 10% of big N. Well, what's little n? Let's start with little n. What's little n? 300. So if little n is 300, big N would be the population where the 300 comes from. We don't have a number, right? But who are they? There you go. If we don't have the number, we write in who they are. Okay, so if we don't have a number, just write in who they are. All students who earned a bachelor's degree. We don't have a number, so we just, if I had that number, that's where it would go. Okay. So if I don't have a number, how do I see if this is true? Well, we can't, right? So it's why it's a condition. We just say, move on, check and move on. Okay. Check and move on. That means we don't have a number for all the students who earned a bachelor's degree. But for this to be satisfied, for this condition to be satisfied, what is the lowest number that this could be? All students. 3,000, right? Are there more than 3,000 students who've gotten a bachelor's degree? Yeah. Since 30,000? Okay, so even 30,000.
Yeah, 0.1. 3,000 times 0.1 is 300.
No, it's 300.
Oh, yeah, you're right.
Yeah.
That's an 80th percentile right there. Yeah, it's kind of the 80th percentile.
So are there more than 3,000 students who have got their bachelor's degree? Yes.
In America?
Anytime.
Oh, in any time? Oh, yeah.
Yeah. Fresno State graduates double that, triple that every year. Okay. So yeah, and that's just one school. Okay. So we're pretty safe in giving that a check. Okay. Done. Okay. All right. So the last question, describe the shape. Describe the shape. So you notice how earlier in the notes there wasn't nothing about shape. We had center and spread, right? We had formulas for center and spread. How do we decide shape? We look at the sample size. Yeah, we use the third condition here. The third condition will tell us what the shape would be. Okay? So we're going to check for normality. Okay? So since it's a proportion, we need to check this out. We need to figure out if that is greater than 10. And we need to figure out if this is greater than or equal to 10. Okay. N, we know that is 300. P was 2.2. So let's see, 300 times 0.2, I think is 60.
Yeah.
So yep, 60 is bigger than 10. That's a check. Okay, 300 times 0.8, that's 240, that's the rest. That's also a check. So because it passes both of these conditions, or not both, this condition, because it passes this condition, we can assume normality. So we say shape is approximately normal. Shape is approximately normal. Because we don't know if it's perfectly normal. So we always use the word approximately. If I can't really see the data, if I can't really see the numbers, I always tend to use the word approximate in front of it. Okay.
And then the work that we did is our justified?
Yep. This is your justification right here. Why? Because that. Because that and that are true. Okay. All right. Now they're going to ask us some probability questions. Okay, so when they ask us probability questions, what is the probability? What is the probability? I put some steps on here. Step 1, define the parameter. Who is the population, right? So that's P or mu, depends on if it's means or means or proportions. Number 2, check all necessary conditions right over here. If it comes from a sample, we got to use these, all of them. Okay. 3, describe the distribution. We don't have to do that unless they ask. Number 3, we don't have to do unless they ask. Number 1, you really don't have to do it either, but we'll do it just because this is your notes, so it's good to do it. Number 3, shape mean is exactly what we just did, but it's a different problem. But that's exactly what we don't have to do that unless they ask us to. Number 4, use the normal model. Right? You guys have done that, drawing it and all that stuff, and then interpret it. Okay, write out a sentence explaining what the probability that you have found means, or what it. I shouldn't use the word means. What it not means in terms of not average. Like what? Explain it. Okay. Okay, so here we go. Bad apple problem. A large shipment of apples on a truck are to be inspected before being sold in a public market. Okay? The inspectors will select a random sample of 150 apples from the truck. If more than 5% of the apples in the sample are bad, the entire shipment is rejected and they won't take any of the apples. Send them back. Suppose that, in fact, 9% of all of the apples in the truck are actually bad. Okay. What is the probability that the shipment is accepted? Okay. So a shipment of apples. So they bring in a shipment of apples. They can't possibly check every single apple. Or they could, but it's just the way it's time eater, right? So what they did was they took a good sample. They take a good sample of 150 apples. They'll check those, right? If 5% of those or less, if less than 5% are bad, the shipment's okay. It can be sold. If more than 5% of them are bad, nope, this shipment needs to go back to the packing house it came from because we can't sell these because there's too many that are bad. Okay. So what is the probability that the shipment is rejected? Okay. So let's follow the steps. Parameter. First thing, is this a proportion or is this a means question? That's the first step. And sometimes that first step is the hardest. It's one of the easiest questions, but sometimes you can get tricked up on it. So is it a proportions or is it a means question? How do you know? Look at the question. How did we know the last one was a proportions and not a means? Okay, so it uses percentages. So I'm thinking proportions already. What's another one? Is the word mean anywhere in there? No. I have 5%, 9%, 150 sample. We're checking to see if it meets a proportion, a percent, right? So this question is a proportions question. Okay. If you're curious as to what a means question would look like, you can look later when you get a chance. We'll do these in class, but the ones at the end of the chat, at the end of the notes, those are means questions. Okay. Okay, so large shipment. So we'll do number one. Define the parameter. So since this one is a proportions question, we're going to say P equals in words. I should have put that. In words. So P is the true, I'll start you off. True proportion of what? Apples that are bad. On the truck. Apples that are bad on the truck. The proportion of apples that are bad on the truck. Do we have that percentage? Do they give us that percentage? They did. What percentage is it? 9%. There you go. So we actually have that. We want to list everything we know. Okay. $150 is N, so I'm going to write that, even though I try to list everything out so that if I don't know it, if I need it later, then I can come back to it instead of having to reread the question. 5% is that, right? They're asking if it's accepted or rejected. So if it's accepted, what has to be true? There you go, yeah. Has to be less than or equal to 5%, so 0.05. right? That's what I'm trying to do. That's what I'm trying to answer. But there's some things I got to do before I can answer that. Okay, so the first one is I got to do conditions assumptions. So let me set up my table here. Okay, so the first one, SRS, the sample of 150. Did they take that correctly? It says random sample, and I'm going to assume that they know what a random sample is, right? We know what a random sample is. We know the procedures on how to do that. I'm going to assume they know they did the same thing, okay? Because it says. So we say stated. Okay. Number 2 is 10% condition. So n is less than or equal to 10% of big N. Oops, number 2. Okay, what is little n? 150 less than or equal to. Do we know the number for big N? No, we don't. So what are the words that we're going to use? Yep, total apples in the shipment, total apples in the truck, whatever you want to say. Okay, good. Last one is normality. It's a proportions question, so we're going to use the first n times p. So n times p is greater than 10, and n times 1 minus p is greater than or equal to 10. We just got to verify those numbers. So 150 times, what is p again? 0.09. So what is 150 times 0.09? 13.5 is bigger than 10. That's a good one. And then 150 times 0.91. That's going to be 136.5. That's definitely bigger than 10. Okay, done. Checked all of them. They all pass. We're good. Okay, so let's go back to the steps. That was step 3. Step 2. Step 3, only do if they ask you to, so we don't have to do that. Step 4, now we're going to get to the thing that looks familiar. Now we're going to actually answer the question. Okay, so now what we're going to do is we're actually going to answer the question in which they've given us. Okay, so normal model. So I need a curve, just like we've done before. What goes in the middle? What's the center? What would be this guy here, the center? 0.09, right? Didn't we say that P was 0.09? It's the same number, 0.09. And then 0.05 is the pass or fail mark. So 0.05 is a little bit less than that. So when are they accepted? To the left or to the right of that line? Less than, yep. This guy right here. That's what we need to find. We need to find that percentage in there. There you go. Z-scores. So it's going to be 0.05 minus 0.09 on top. What's the bottom going to be? Or how do we figure out the bottom? Or did they give it to us? There you go. Yep, it's right on the board right there. Standard deviation, it's the one that's given. This one right, where is it? Here. Standard deviation for proportions. So we got to calculate that number before I can put it on the bottom. So let's see. What was it? N. Or sorry, P. So 0.09 times 0.91 over 150. 0.0233. 0.023. That number goes on the bottom here. Okay. Divided by 0.023, I get a z-score of negative 1.74. Okay. Go to your tables. What do you get?
0.0409.
0.0409. Now, is that our percentage, or we have to subtract from 1? That's our percentage. Yep, that's our percentage. You are correct. Because it starts from 0, right? The shade, if I shade left, that's our percentage. If I shade right, I got to subtract from 1. Good. Last thing, explain to me what that number means. It's a percent, right?
The 4.09% chance that the shipment is going to get rejected.
Close.
Really?
No, wait.
Oh.
Wait. So what does the yellow mean? The yellow means accepted, right?
Right.
Yep. So what's the probability it gets accepted?
4.9% chance.
There is a 0.0409 probability, or a 4.09%. That the shipment is accepted. Okay. Does that make sense in context of the problem?
Yeah.
Why? Yes, it does. You're right. Why? Pretty small chance that it's going to be accepted.
Because you link the percentage back to the question.
Yeah, exactly. Specify the. So there should be a very small chance that it gets accepted. Because why? Exactly. We know the true answer. The true answer is you should get rid of this. Don't accept, right? So there's still about a 4%, but 4% is pretty small, right? So in order for me to accept this, knowing that, hey, this shipment we shouldn't accept, it's pretty small. So let's say we didn't know 0.09, but we get this percent. Are you going to accept that, or are you not going to accept that? So let's say we didn't know, like, because they kind of cheated a little bit. They gave us this number here, right? And how in the world do we know that number if we're taking a sample, right? So in real life, you won't know that number, right? This number we won't know in real life. Okay. So let's say we didn't know that number, but the data comes out like this. Are you going to accept it? What decision are you going to make? You're going to reject it. You're scratching your head. You're like, there's about a 4% chance that this is actually going to be accepted. That's not good enough for me. Okay, you're going to reject it. Yeah, absolutely. 4% is pretty low. Okay. Right? If it's somewhere in the middle, if it's a little better, maybe you take another sample and try it again. But this one is pretty low that there's no way I'm going to accept that. Okay. Okay. Let's try. Okay, so I want you to try this one. Try the next one on your own. Give this one a shot. If we run out of time, we run out of time. We'll finish it tomorrow. But I want you to at least get some of it done. So use the steps. Okay, so we got about 2-3 minutes left. Stop where you're at right now. We'll finish the rest tomorrow. First thing we do is I'll give you some time to finish the rest. Okay.